Hello everyone, this is Reza Rahaimer. Today I am going to talk about Universal Composability Analysis of OpenStack, which is a joint work with Rand Canetti, Martin Van Dijck, Jason Hennessy, Kyle Hogan, Hoda Maliki, Mayank Baria, and Hyben Zhang. I will talk briefly about cloud computing and OpenStack and security concerns around them. Then I will introduce Universal Composability as a security analysis tool. We will see why we think universal composability is a good choice for OpenStack security analysis. Then I will explain the analysis approach and the steps need to be done. And finally, a conclusion will be given. Nowadays, with high probability, you face these kind of scenes in big companies and organizations. They are main part of infrastructures of modern businesses and governmental organizations. Before emerging the cloud computing technology, managing of this infrastructure, deploying new applications, running multiple applications over those at the same time, scale up and down the share of each application, providing different security needs of each application, protecting an application against the vulnerability of the other applications running on the same infrastructure was almost an impossible mission. Based on Wikipedia website, cloud computing is a type of internet-based computing that provides shared computer processing resources and data to computers and other devices on demand. The term on demand is very interesting for admins and users. Cloud platforms enables cloud computing. It is a middleware, a combination of software and hardware, which sit over your hardware infrastructure and provides a software interface for the admin of the system. Using this interface, an admin is enabled to define virtual software-defined isolated computer networks and data storage. I repeat it again, virtual software-defined isolated. Now you can set up your application on any of these virtual computer networks, scale them up and down by just clicking some software buttons. You have your own computer network for installing and using your application, a dedicated network just for your application. Perfect. But wait a minute, nothing is perfect. Unfortunately, these are all ideal. There are many issues in the real world. Let's count some of the most important ones. First of all, cloud platform involves huge code base. Software remains bugs for the software engineer and even for users. Bigger software, more bugs. Second, usually several applications are executed on the same cloud platform. Are those really isolated? Of course not. Why? Because all cloud applications are using same infrastructure. Although they are virtually isolated, but still many attacks like side channel attacks are possible. In addition, as I mentioned before, cloud platforms have many bugs, so the isolation provided by this platform is not reliable. Third, each application has its own users with different privileges and capabilities, and some cloud services are open to public. In practice, a cloud serves many people, and this environment is very interesting for hackers. Number of attackers and hackers that are attracted to the cloud services are growing rapidly, and privacy of users and data confidentiality are in. Now I want to talk about a cloud platform, OpenStack. OpenStack has an outstanding position among all cloud computing platforms. because it is a reliable open source software which is available for everyone. It is fully practical, widely used platform, mostly deployed as an infrastructure as a service. OpenStack is composed of many modules. Each module can make use bunch of plugins. OpenStack takes advantage of community-based development model, and many developers are contributing in OpenStack development around the world. It is growing very fast. It is developed and released around 6 months cycle. At the highest level, OpenStack is composed of large modules called service. Each service has a specific independent duty. To have a fully productive cloud, you need to make use of 6 services. Swift provides object storage for your cloud. Keystone is responsible for authentication and high-level authorization. Nova takes care of compute resources. Nova, in fact, is the core of your cloud. Neutron enables networking. Cinder serves as a block storage, and Glance provides image services such as uploading operating system images, create image of current virtual machines, and so on. Beside main services, there are a bunch of useful services that you can take advantage of them, but they are not essential. You can see 17 services in this list. The length of this list is growing continuously. OpenStack is a cloud platform, so it suffers from common cloud platform issues. In addition, I mentioned that it has huge codebase which is developed by different communities around the world. That makes security analysis of OpenStack very difficult. It goes even worse if you know there is no clear security model and the API between components are not well defined. OpenStack makes use of many plugins, and almost in all cases, admins have the right to choose between a bunch of plugins. Each plugin has its own vulnerability. All of these issues shows why security analysis of OpenStack is very important. Let me introduce universal composability as an approach which may be useful for security analysis of OpenStack. Universal composability is a general-purpose model for security analysis of cryptographic protocol. We think it is perfect for modular systems where interaction between modules are very important. It provides common understanding and common language of system security. It was introduced by Ran Canetti in 2000. The goal of this project is better understanding of OpenStack security guarantees for OpenStack users and customers, assist in identifying highest impact security improvement for OpenStack developers, formal definition of OpenStack security-related functionality for cryptographer, study the security interfaces between components which has not been studied well. To achieve these goals, we must follow these steps. First, define functionality of ideal cloud. Second, define functionality of ideal component. Then show that components realize the ideal cloud functionality. Propose OpenStack modifications to realize the functionalities. Propose component implementations that realize the functionality. In first step, as I said, we must define functionality of ideal OpenStack. Ideal OpenStack is a ideal black box that do the task accurate in no time. In this model, user is part of environment which potentially can be an adversary. In this step, we must specify the ideal functionalities of an OpenStack. Create node, delete node, upload image are some examples of ideal functionality. It is necessary to mention that the OpenStack is assumed ideal, but the communication between OpenStack and environment is not ideal. So even in this model, ideal OpenStack leaks some information to the environment and influenced by adverse. After defining the ideal OpenStack, we need to take a step down into ideal OpenStack. We split the ideal OpenStack into several main modules, which in fact are OpenStack ideal services. We assume all services are ideal, but the interaction between them is not ideal. In this way, we make the hybrid OpenStack. Now, we must inspect the new model and find out what are the extra leakages, how much they are important, and how we can mitigate them. If everything is okay, we must show that the ideal world and the hybrid world are indistinguishable, but they are not. The information leakage in hybrid model is more than ideal model. Now we add a simulator to the ideal OpenStack. The simulator must emulate the extra leakage. By using simulator from an environment view, both systems are the same. Then we must split each of the ideal services into some ideal components and make more realistic hybrid world. We keep repeating this step until we get the real world. If we get there, we can say the real model is secure as an ideal world. Otherwise, we must propose a solution if it's possible. As you can see, this step-by-step universal composability analyzes both the security bottlenecks and issues. In this slide, the ideal model is shown at the left, the middle picture is the hybrid model, and the right picture shows the real OpenStack. If we can prove that the hybrid model realized the ideal model, and the real OpenStack in fact realized the hybrid model, we can say that the real OpenStack realized the ideal OpenStack. We talked about the security issues of OpenStack and find out that OpenStack security must be analyzed in depth. In this way, UC is helpful too. By applying UC, we will get better understanding of cloud security model and we will discover cloud security bottlenecks and concerns. We find out that it is possible to model practical systems and improve the security of systems by applying UC. It is time-consuming task and needs lots of expertise. Thank you, everyone.